Cool. Are you guys ready? We'll get started. Does everyone have a coffee? Cool, even better. My name is April Edwards. I'm a senior cloud developer advocate at Microsoft. I'm the DevOps practice lead. So today we're going to talk about GitHub and Azure. How many of you use GitHub? How many use Azure? Even better. Perfect. We're going to talk about the better together story. It's one you probably don't hear enough of. We're going to deploy something live to Azure. So pending Wi-Fi, we're going to do a live demo. I am based here in the UK. I'm based just down the road. So feel free to reach out to me on Twitter or LinkedIn, ping me with questions afterwards. I'm going to be at the Microsoft stand the entire day hanging out. Please bring me coffee and alcohol because it is my birthday. Technically tomorrow, but tomorrow. Yeah, bring me liquids. So yeah, I lead up the DevOps practice globally at Microsoft, meaning anything from DevOps practices, infrastructure as code. Infrastructure as code is where I spend a lot of my time, automation. I have an ops background and I moved into development because ops got boring and tedious and I hated 3 a.m. And I was like, ooh, development's fun, code and all these great things that we can do. So we're gonna go ahead and get started today and talk a little about DevOps. So I wanna set the stage a little bit. How would you define DevOps? And yes, this is going to be an interactive session, so I hope you brought coffee. Go ahead and you can shout it out. Don't be shy, we're all friends. How would you define DevOps?
The union of people.
Shh, you're spoiling it. No, it's okay, you can say it. But I think all of us have a different idea of DevOps. Our backgrounds, our current job titles, our experiences. We think of as automation or all these things. But I want to level set how we define DevOps at Microsoft. We define DevOps as the union of people, process, and products to enable continuous delivery of value to our end users. And I want to focus on this word value because we're all going to use different tools, we're going to use different things, but the DevOps change is 80% the cultural people change. So we can talk about all these great tools and all these great things, but if we don't embed that culture, we're not going to get anywhere. We have to help our developers be better developers. So we're going to talk about GitHub and Azure and what value it can bring to your organization today. So we all talk about DevOps as not just a theory, but an actual contextual thing we can put numbers behind. So we know that high-performing DevOps organizations achieve more, and we know that because they deploy faster. They have faster time from commit to deploy. They have faster incident recovery. At the end of the day, that's great for us. Those are numbers we can hand back to organizations, say, we're achieving more, and here are the stats. But the reality is our organizations want a faster time to market and an increased revenue. Because if we're not making money, we're out of job, right? We have to be able to deploy those things and show that relevance. And these are the stats that we can bring forth to the organization. It changes how we present our numbers to organizations. So I like to talk about vulnerabilities. In DevOps, we use this phrase, shifting left, doing things early and often. I like showing this one because as a developer, I'm like, yeah, I don't really care about money, but we've all been there. We've had a breach, we've had an issue, and when we find that issue in production, it costs us more than remediating it earlier in the process, in development. The cost to remediate these things in development is a lot cheaper. So I'm going to give you an example of a couple breaches we've had. I love Uber. Uber gives me so much content when I talk about security, DevOps, all that good stuff, because they're exposed all the time. In 2017, Uber had a breach that was found in production that cost millions of users' data to be breached. That cost them money in terms of, as an organization, what they had to pay out. They lost trust in their customers. They've had another breach. Does anyone know what their current breach was about? They put a password in their code. They had a PowerShell script, and they put their password in the PowerShell script and pushed that to production. So it sat in their GitHub repository. The development phase, something that is easily fixable. So we're going to talk about those things that we can remediate. So doing those things early and often is really critical. We have lots of other organizations that have had breaches that are well known. They're in the news. Capital One, Equifax, these are US-based companies, but they each had breaches in their hardware configuration because they didn't update it, and these things occur in the development process. How many of you have put a password in a file somewhere and said, I'll deal with that later? Oh, I've done it. I'm in a rush, I'm stressed, whatever. I've done it. And that's that development phase that we want to try and mitigate. Now, again, we need to justify to our organizations why we have jobs and how we're going to do this. So we need to think about starting secure and staying secure. So you may not be a security expert, but as a developer, I need to be concerned about security, but I do kind of hate talking about security because it isn't my thing. But I have to start thinking about it in that development phase. So again, we talk about shifting left, and I like this because many of you have probably worked in like those waterfall models where we're doing things after the fact. We're doing things in production. That cost is really heavy to the organization, and they usually don't get done. And they're usually a pain in the butt to put in after the fact. So we want to do things early and often, and we want to fail fast. That's why I want to do these things in the development phase. So what does the GitHub and Azure story look like? So we have GitHub, and we can secure our environment. We can embed that security in your developer workflow. You don't have to be a security expert. These things are easy to enable, and then we can deploy that into Azure. So I love this graphic because this shows us everything that we do from the development side into the security side. So if we look at the development side, how we develop, how we write our code. Security starts when your developers clone their code. It sits on their machine. What tools are you using? How many of you have been given a machine and it's underpowered? Yeah, and most of our developers get that all the time. I was working with a customer in Europe, and their developers were given these really crappy laptops, like really, really bad laptops. And it took us weeks to get them set up onto the project. They weren't allowed to run Visual Studio Code because it was an enterprise level product. They couldn't access GitHub. They couldn't do anything. They were using Notepad++. That was a hoot. So we're working on this customer project, and one of the engineers says, April, I have an issue. Sure, what is it? I can't find this issue in my code. Okay, let's have a look. Pull up his code in VS Code. I said, oh, it's right there. He goes, how'd you find that? Well, I'm using VS Code. I have an extension for Terraform, and I can see exactly where you kind of misspelled a little thing. I caught it in 30 seconds. It took him 4 hours in Notepad++. So the tooling does matter, how we allow our developers to do things. We're going to talk about GitHub code spaces today. How many of you have waited weeks to get started on a project? Yep. Or how about, but it worked on my machine? Yeah, that's my favorite. I have a great little set of dice at home that's like, developer excuses. It worked on my machine. It worked yesterday. When we start enabling ourselves to develop better code earlier on in code spaces, that helps as an enabler. I'm going to show you code spaces to deploy our code today. Why I love code spaces. It's a secure environment. As a developer, I don't want to think about all the things, but if I can give my developers that secure environment, and if I'm working on a Mac or a PC or a Linux device, it doesn't matter. It's a continuous environment for all my developers to write their code. I can secure it, and we can get it running up in seconds. Now, internet dependent. So we'll see how today goes, but so far the internet's been really good here. The other thing is I'm traveling, and I need to access code. I don't have my device with me. I'm one of those weird unicorns in tech. I don't travel with a laptop on vacation. If I go on vacation, I bring a physical book or 4. I don't want to see my work. So if there is a problem and there is a meltdown, which has happened to me in the past, and I need to access something, how do I get access to my work if I'm in another country? I can pull up a web browser, spin up my secure code space, and do what I need to do. Also thinking about working from home. How many of you have pets or children? I've got a dog. He's cute, but his face touches my laptop, right? So what if I have code open? What if I have things open? What if you have children in the room or spouses, partners? They don't need to be able to access these things. So having a secure space, you can do your things and get started quickly is why we're going to talk about code spaces. GitHub repositories, right? Where we keep our code matters. Not on your local machine, not on a server, in a repository. We're going to deploy some stuff with GitHub Actions today, and we're going to put in all this cool stuff called GitHub Advanced Security. How many have used it before? Not many. A couple, okay. So we're going to go ahead and embed that into our workflow. As a developer, it's built in for me. It's going to help me catch those things before it goes to production. We're going to talk about Azure Container Registry. So we're going to deploy an app today that is containerized. I can deploy that to AWS and GCP. We're not going to deploy it to the other clouds today, but I can show you a dashboard that will enable us to do that. Now, for those of you that work with security teams, we want those people in the security discussions from day one when we start a project. So we've got a ton of other tooling that hook into everything that we're going to do today. We're not going to go through all of this, trust me. It's a lot of stuff. But how we log into things, our Azure Active Directory, how our apps are configured, how we're monitoring our apps. We can hook in a SIEM service like Sentinel. So all these things can hook in. Things I love are being able to use Azure policy in our pipelines and say, you know what, we have a policy in Azure, our pipeline can't continue. That's built into my pipeline, and that protects our production environment. So where does security fit in the development lifecycle? So remind me again, where does security start? When does it start, sorry? Who remembers? When your developers clone their code. That's what we have to think about, right? Not even when we commit our code, where are we developing our code? So in this pre-commit phase, security fits in the whole thing. You know, what kind of threat modeling are we using? IDE security plugins. Are we using plugins into VS Code? Are we using something like GitHub code spaces? We need secure coding standards. And one of the simplest things to implement is peer review. How many of you don't do peer reviews on your pull requests? I see hands and eyeballs rolling. I won't name names, won't point fingers. This is a judgment-free zone, by the way. This is a safe space to talk about it so we can help you do better in the future. These are easy things to put together to help you enable each other. When we commit our code, are we doing unit testing, security code analysis? Are we scanning for our dependencies? What about credential scanning? What are we doing to help that? Because we've all pushed a password to GitHub. When you push that password to GitHub, it stays in your history. You can delete that password, it's in your commit history. All you need is someone with Trufflehog or another application to go, oh look, I see April put a password there 6 days ago. She deleted the password. I still see it in her commit history. They can still obtain those passwords. So when we deploy everything, are we using infrastructure as code? I love infrastructure as code because it enables developers, it enables operational people. I worked for a company in the UK. I won't name names because that's not fair. Not Microsoft, by the way. I worked for an MSP. It took us 4 days to deploy a server. 4 days. In 4 days, I could build a house. I can't even deploy a server in 4 days. Why? We had a physical checklist to deploy a server. Everything was manual, and that's how we justified our existence. I feel so sorry for those customers because they had to wait 4 days when they requested a server to be built. That is why I started loving infrastructure as code. That's what got me into Azure. That's what got me into, I hate to say it, ARM templates, but it's also why I hate ARM templates, like with a passion. But that's all the story. Infrastructure as code, are we doing that? Are we testing our code before we deploy it? Are we using infrastructure as code? Are we just pointy clicky things? When we're deploying, are we using security scanning? What kind of cloud config do we have in place? Then when we get through all these things we've done, are we monitoring our operational space? I was working with a UK customer, and they're literally doing all the things in the first 3 cycles, all the things. They weren't monitoring what they were doing. And they're like, well, we're doing all the DevOps. And I'm like, okay, what are you missing? They're like, we're not doing any monitoring. Why not? Well, we're doing all the other things. The monitoring is going to give them that feedback that A, gives them metrics, right? How long does it take for us to find that there's an issue? How long does it take for us to remediate it? Then how do we plan our next sprint cycle? If we don't know what's wrong in our environment, how do we plan that? So I have all these slides that talk about code spaces and all these things. That's cute. Who's ready for a demo? Okay, me too. Yeah, there's lots of great slides here. If you guys want to see copies of this, I'm happy to share it. I'd rather just get on with it and show everyone all the cool stuff because that's why we're here, right? Right, let me just change my screen around because demos are fun. Right, this will make it easier for everyone. So we have a website here. This is just a generic website, nothing too fancy. We have a website. We're going to make some live changes to our website. Now, this is our production website. You see at the top it says web app-prod, production website. I just keep prod in there so it's visible. There's a lot of things we want to do here. We want to make changes to our code. We want to do things early and often. And if something doesn't work, we want to fail fast. The other thing we want to do is make sure there's testing end-to-end. So we're going to do a lot of the tooling. We're also going to talk about some developer practices in our YAML file, in our workflow file, in GitHub Actions to protect our production environment. So we're literally doing everything end-to-end. Is it perfect? No. But it's a great start. So everything I'm demoing today is in a public repository. You can take my workflow with you, give it a shot. You can fork the repository. It's not the best workflow file. It needs a little bit of TLC. But it's a great start if you want to get somewhere. And a lot of things we're going to do is going to be out of the box. So we have a website. So remember, I'm going to be working off VS Code. This is my code for my website. I've got some code in there. I've got some documents. Up at the top left, you can see I have some workflow files. I have a multi-environment workflow. We're going to go into what this workflow does more readily in a couple minutes when we review the workflow files. But I need to change my workflow file before I get started. Our login to Azure is expired. How many of you have had that happen? Yeah, we'll talk about service principals in a minute. Yeah, I need to fix it. And, oh, there's a new password. I'm just going to put it in my code. Now, we want to stop our developers from pushing their passwords and secrets to our repository, right? So we all do it. And this is a terrible example, but a great example at the same time, because I probably wouldn't put my credentials like that. But I might put a connection string somewhere. So I'm going to push my code up to GitHub. I can't. I have enabled GitHub push protection on my repository where my code sits. So I'm a developer working on my machine, and I've put a password in because I'm having a bad day or not enough coffee. It has blocked it. So let's look at what's happened. So let me make it a little bit bigger for you. OK, that reads terribly. Can you guys see that? Is that OK? Cool. So right, I have a blocked push. It tells me I've made a commit. It's giving me the shell code. It tells me which file and what line. So I can see on line 75, which obviously we all can see up there as well. I have to remove the secret. Then I can push my code forward. So it has detected that secret before my code has even gotten into my repository. So something you're going to see in the industry is, we keep talking about this AI thing. There's a lot of tooling that's going to come closer to your developers. How do we improve their life? Because as a developer, I'm having a bad day, I'm in a rush, I just need to do this thing. I'm just going to test it quickly and fix it later, right? Fix it later. So I put my password in there, and my admin's gone, hold on, we have push protection. They've helped me as a developer from doing stupid stuff. They've enabled me to be a better coder. So I have my password in there. All right, we'll fix that. Push protection doesn't support everything in Azure yet. It does support connection strings, Azure AD passwords, and a few other passwords. This product got released at Build in, my years are getting confused, Build 2022, so almost a year ago. We launched this. There is a video on the Build website. The demo is exactly what I just showed you. I know this because I wrote the demo and I did the video. But I've enabled push protection. So I'm going to go into the repository in a little bit and show you how I've done all this. So I've stopped my developers and myself from doing something really stupid. So this is the repository I'm going to access. This holds all our source code. So let's pretend that I can't use VS Code, right? My machine just isn't working today, which happens a lot, ironically. I'm going to go into my code here. Now, there's a couple things we can do. If I'm in my repository, I can pull up a web editor. How many of you know about the web editor? If you hit a period or a full stop, it pulls up the web editor. So we're going to let this roll. And this will load my repository source code. This is literally an editor. I get none of my extensions, but I can make a quick change if I want to. I can see which branch I'm working from. I can do all the things, but I can't run any tests, and I'm really, really limited in functionality. The web editor is great when I just need to make simple changes to my code. It's not secure in the sense of it's not a secure working environment. If I go to run and debug my code, you can see it's trying to load all my extensions for me. I can't debug and run my code from the web editor. So I like to use the web editor for a wiki change or something really simple like, oh, quick change web editor. I don't love working from the GitHub interface. And maybe I'm having a Git issue on my VS Code because that happens all the time. I am like the queen of merge bombs when it comes to Git issues. So, right, I can't do everything, but I can make a quick edit. I can change my working branches here. I can do all sorts of stuff, but I can't do all the full fat of VS Code and Visual Studio. So that's cool, but let's go back. That's a nice little thing to find out. So if I go to my code here, normally I clone my code to get started on a project. And when I've worked with customers before and we're like, yeah, we're gonna get started, we're gonna clone our code. Oh, I need to install all these things. I got prereqs. Yep, that's gonna take a while. And that's what takes forever getting started on a project. I just want to get started. So instead of cloning my code, I'm going to open up this code space. I'm going to create a code space off of my main branch. So what code spaces are doing, it's setting up a containerized environment that's secure for my developers to work from. Because I don't have a dev container in this repository, it spins up a default one. So let's talk about dev containers. How many of you use dev containers? I should have put in a dev container component to this. All right. So a dev container is our secure environment, package environment. So again, I talked about it doesn't matter if you're on a Mac, a Windows device, or you're running a Linux OS. If we work from a dev container within VS Code and code spaces, we run the same tests and everything's pre-installed, ready to go. So in this repository, I'm running a few bits of code. I can build all the prereqs, all my testing tools in that dev container. So my developers don't have to install those things. So every project should have a dev container. So this is spinning up the default one at the moment. And as it spins everything up, let's see if I can get it to make it prettier, bigger, really. It's loading all my extensions here on the left-hand side. So we can see everything loading on the left-hand side. So what I could do is I could pick on Cliff over here in the corner because he looks bored. And I could set up a live share with Cliff. How many of you have used live share? How many of you tried to help someone with their code in Teams before? How many of you enjoy that experience? Yeah, me either. I helped a colleague one day, and I was literally banging my head against a wall. Live share is coming to Teams. I don't know if it's been released yet. I don't think it has, but it is coming. But I can set up a live share coding experience. So I can be in my code space working off my web browser anywhere in the world. My colleague could be anywhere in the world and spin up a code space and join my live share session. I can also join from another Visual Studio Code experience or another Visual Studio experience. Live share is compatible across all the platforms. This is literally VS Code in a packaged environment. I can also run and debug my code. I can run my tests here within this dev container. Now this gives me a scaled out containerized environment to work from. I think the standard, you can configure dev containers. There's a whole billing process around it for compute power. So if you want 2 CPU and 4 gigs of RAM, or you need to scale up, you can. So your developers can start with that really small environment and scale it up as you need more. Because sometimes as we're running tests and things, as we're pushing our code up, we need that higher compute power. So if it isn't available on your laptop, we can run it here in the code spaces. So we can do all these things in code space. I have full functionality, which is pretty cool. I'm a big fan of code spaces. It has unblocked me in so many scenarios where it's taken people so long to get ready. I can pre-install all the tools they need for everything, and then we're good to go. So you can see down here on the left-hand side, I'm running a code space. Before we change some code, I'm going to create a new branch like a good developer. We're going to call this NDC London. Just put my name on it. I'm going to go from a new working branch. So I'm just going to I have a little index page here. And we're going to change our website. So this is my website. Great. I believe there's another line here. Welcome. Oops. It is 2023, right? Cool. So I've got autosave enabled. On the left-hand side, it's like, OK, you've made some changes. Great. I'm going to go ahead and stage those changes. Yep, I'm happy with them. We've changed our website. I need to put in a commit message. Now this is great. So if we think of another use case, not only are we traveling, how many of you have been asked to spin up a web server or a website for someone yesterday? Right? So the reason why we've made this an image is because we don't have to deploy infrastructure behind it. Well, we are going to deploy some infrastructure behind it, but not too much. So this is a great use case where we can spin up stuff really quickly and send this out. So I'm going to go ahead and push this commit in. And it's going to publish our branch at the same time. And if I go back to GitHub, we can see that I've changed it up to my branch. We can compare and do a pull request. Now, the other thing we can do, and I skipped this step, let's create an issue real fast. Need changes. Sounds like the story of my life. I needed this yesterday. OK. So GitHub's like, oh, you've pushed some changes. Let's create a pull request. We're going to just call it change to website. It's picked up the name of my merge. I can add myself as an assignee. I can put in reviewers. I'm going to pick a colleague. He's not online, but we'll just pick on him because it's fun. I can add labels, right? So I want to make changes to my project. So it's put this pull request in. But I need to put some tracking in. The one great thing about DevOps is traceability from beginning to end. We can see that we've made changes to our code. Our code sits in our repository. I've created an issue, albeit late, and I've created a pull request. So if I hit the pound sign, I can see my issue. And I can link my issue in there. And we create our pull request. So every time I create a pull request, it's going to do some fun things in a moment. It's going to run some checks. So I have it set in my environment. We're going to run this multiple environment workflow that we saw very briefly. We're going to go through it in a minute in more detail while everything's running. And I'm running something called code QL analysis on every single pull request. So I showed you that we have push protection. So before I push my code in, I can stop my developers from doing passwords. But then code QL is going to analyze our existing pull requests. So every single change is assessed when we push that to GitHub. Because we're not going to catch everything, unfortunately. So that's why we use multiple tools. So while everything is running, we're not going to watch paint dry. Let's go see what's actually happening. So we can see these two things going. I want to talk about code QL first, because there's a lot of things going on in the repository that I think are really valid to talk about. So if I go into my code QL job, we can see it's running. It's initializing code QL and doing all sorts of things. There it is. So what is CodeQL? CodeQL is analyzing my repository, and this is a basic workflow that it spits out for me. When I enable CodeQL, it's going to run. Now we can see I've enabled it on every push to my main branch and every pull request. I've also put in a scheduled job. I put in a scheduled job because I want to make sure this runs to pick up anything that maybe someone put in there without a pull request. Now we can use branch protection, there's requiring pull requests, all sorts of things that we want to do to enable our developers to have better development practices. So I put in a cron job just because I want to know what's going on at all times. And this is the default workflow it spits out. Now it's read that I've got JavaScript in my repository. I didn't tell it that. It picked that up on its own. It also supports things like Go, Ruby, Python, and C#. So it will pick up the language you're running and run against that code. As soon as it goes to run through that, it will initialize CodeQL as an action, builds our code, and will perform the CodeQL analysis. So that is running every single time. So I've enabled that in so that I can see if there's any issues. So we're going to let that run and come back to that. So both our jobs are running. So I'm going to go through the security pieces that are enabled. Now, I'm going to use a different repository because this repository has a lot of security issues, and it's quite a train wreck. It's very similar to one we're doing, but I love using it for security stuff. So when I go into the security tab here, I can see a few things. So I can see secret scanning, and it's been disabled. Okay, that's nice. Go into code scanning. So in the code scanning, this is also using a CodeQL workflow. So this is using exactly what I'm just running. And in the CodeQL workflow, it's seen that 3 weeks ago I did a scan because that was the latest pull request. It tells me what pull request went through, how many lines of code it went through, how long it took, and there's an alert. And it opens that alert, and it says you have clear text logging of sensitive information. So if I click on the alert, I can see exactly what happened and when. So it tells me where my attack surface is. It tells me what branches, again, tags with security and a high severity. I can then remediate this really quickly. So this is something already sitting in my repository. So how do I configure that? If I go into my settings and my code security and analysis, I literally click the enable, right? So I've gone into CodeQL here. I've enabled it, and you can put in other tools. So I always tell people, enable CodeQL analysis. You can modify that workflow. You can add in other tools. If you're using other tools today, like CredScan, et cetera, you can add that into the workflow file. I can also put in a protection rule that says a pull request check failure. So if errors are only listed as high or higher, I can fail my pull request. Maybe I work for a very sensitive organization, and I need to go medium. And then you can also customize this. The next thing I'm going to show you is Dependabot. When we work with open source software, it enables us to do more. But when we have software embedded into our code and into our projects, we need to know when a dependency exists. Is there something that's out of date? How do we measure that? That's where we have Dependabot. We turn on Dependabot, and it'll give us alerts. So if I go into my security tab again, we can see Dependabot. I have 79 alerts. So here's a critical one that opened up 2 months ago. I can look into it. It tells me the affected version. It tells me what NPM package I have installed and what patch version I need to go to. It also gives me the attack surface. Now, as not a security expert, I can hand this off to my security team, or I can go into my sprint cycle to remediate because maybe it's tagged as a high and that's our policy as a team. But it can see these dependencies, so I can know how to patch it, how to update it, and how to move on to my next sprint cycle. Let's see how our actions are doing. Okay, so we have our workflow is still going, but we'll go through it while it's running. So it's taking about 3 minutes. So our workflow is doing a few things. I will open up the workflow file so we can have a quick look at it. So this gets triggered on every single pull request. I've put in branch protection, so I can't do anything outside of that. The first thing we're going to do is build and push a Docker image, because I want to take my code, I want to package it up, and then we're going to log into Azure. And notice I don't have my secrets exposed in my real workflow. And then we're logging into Azure Container Registry, and then we're building and pushing that Docker image. Now, when that Docker image goes into Azure, if we go down a little bit more, We're scanning our images using Microsoft Defender in Azure Container Registry. So I've prevented myself from putting in passwords. I'm putting in scans into my infrastructure to ensure that's correct. And then once it passes that, it then deploys the container. Once it deploys the container, it's then going to go into different environments. So I'm going to show you all the little different picture, because we all like pictures better than words sometimes, because YAML's boring to look at. So if we see on the left-hand side that we're building and pushing our image, we're deploying our container, and we see on the bottom here, there's this little container scan thing. I'm going to click on that. This gives me the container scan result. So remember, we're building and pushing an image. That's going to be our website. And we have one warning, 2 informationals, and a fatal. That's interesting. So we can see our image. We can see the SHA code here. We can track that. We have full traceability. And it'll tell me the best practice violations, but no vulnerabilities, actually. So if I go into the Microsoft Defender that's sitting in Azure, I can have a closer look. So the reason why I really like Microsoft Defender is because it's multi-cloud enabled. The majority of our customers sit on multiple clouds, not just Azure. So when you have a footprint in AWS and GCP, you can get your security posture in those 2 other clouds as well. This enables us to see across the different clouds, because the reality is we're not all working in Azure 100% of the time. I can actually go into my scan. Let me give this a little refresh. So we can see that where I have my container registry, I click on it, it scanned my images, and I should have one that I just pushed. It's not in order, because that would be helpful. All right, I don't see ours listed in there, but I'll pull up a previous one. I can go into the container scanning. I can see the vulnerabilities. I can see the SHA code over here on the top left. And then I can see where the vulnerability is. It's an Alpine Linux security update that's in my image, so I need to resolve that. Again, we can set these things in our workflows to fail. Now, I've let this go because it's a fatal warning for best practice, but it's not a vulnerability, so it hasn't failed my workflow. And if I go back to my workflow summary, we can see the same stages here: build and push our Docker image, create and deploy our Docker image, and deploy to a test environment. So the other thing I'm doing here is I'm deploying to multiple environments. Here's my production environment here. I'm deploying to these different environments. I've also exported out the web link, so I can go to my website and go, have our changes made it through? This is where we need like a drum roll or elevator music or, come on, you can do it. There we go. So our website deployed to our test environment. So we stopped ourselves from putting in a password that we shouldn't have. We're running CodeQL, that passed. We're going to our test environment. This is where we can test our actual infrastructure and our performance. There's things we can hook in like Azure load testing and say, how is our app performing? We can hit it with traffic and see how it does. We can run all the tests, all the things, and go, you know what? It's ready to go. We can go to the next environment. So I actually have a physical manual review. I like doing manual reviews, usually to production environments, but also our staging environments, depending on the sensitivity of our data. So I'm going to say, yes, I like this. It can go to staging. Yes, everyone is happy. Is everyone happy?
Yes.
Cool. So we're going to approve and deploy that. And it's going to deploy the staging environment. It's going to do the exact same thing. It's going to deploy our code out to a staging environment that's identical. So my test, staging, and production environments are identical web apps, separate physical web apps from each other. Yes, you can use staging slots, but in this case, I'm using very individual web apps configured the exact same using infrastructure as code. So this will deploy, and we should have a website in a minute. Let's see what our CodeQL scan did. The good news is there were no failures in our CodeQL scan. Everything's happy. We can click on it and go, right, it performed everything. I can see what the CodeQ analysis said and really read through that if I want to. So it counted 124 lines of JavaScript, no issue. So everything passed. And again, we can set this for failure. And that CodeQL analysis will pick up any passwords or sensitive logging information that might be in our existing repository. So our website's still rolling out. Let's see what it's doing. It's deploying to our staging environment. So it's deploying our infrastructure. So I'm deploying net new infrastructure every time. Believe this one's using Bicep in the back end because I absolutely hate ARM, like with a passion. I hate ARM. And if you're using ARM, I'm sorry, I can't. So, and we'll just set up our container, get our web app URL out, export that out, and we'll have another environment. So while this is running, does anyone have any questions? Because I've thrown a ton of stuff at you. Yes?
So is CodeQL similar to SonarQube?
Similar, you can hook in SonarQube to your CodeQL workflow. So your CodeQL treats your code as data. So it scans it through. You can hook SonarQube in for additional security tools as well. What GitHub has done with GitHub Advanced Security is to give you an out-of-the-box answer, because if you used Azure DevOps previously, you had to get SonarQube, et cetera, and licensing for that. Yeah. So we can easily add in SonarQube. So actually, let's do that. Let's add SonarQube into what we're doing. It's pretty easy to do. And I have customers that have invested into that product. Okay, well, I'm not going to set it all up. I'm just going to show you the pretty side. I'll get you in just a second, sir. Let's go to the YAML. Again, I can edit it in here. I can open up, oh wait, is our, no it isn't, I shut down our workspace. Again, I can spin up a workspace, but we can edit it here and go into the, we'll actually do it from the marketplace. It's easier to do it from the marketplace. Am I unable to spell today? You're right. So I'm out of coffee today. How's your morning? Right, cool. Yeah, so if you have others, so you can hook these in as GitHub Actions into your existing CodeQL workflow. When you see anything that has the validated check mark, what that means from GitHub is they verified the organization, they verified the action that's coming through. The other question I've had about actions is how do you validate them, because they're written by third parties. You can write your own action. If you are using SonarQube, you can write your own action if you really want to. For something like SonarQube, the third party produces the actions to put in your workflow file. So you have tons of options here. You could literally click on this and add it in. So if you wanted to throw in SonarQube scan, use the latest version, you can go down and choose a version if you're on preference to a different one, and it will spit out this action here. So I can literally copy this out, go to our repo. I mean, personally, I'd rather do this from, I could also do this from the code space as well. And I could go in and literally builds our code, performs the code. I could put it before my CodeQL analysis and hook it in here. Or we could create a whole new, a lot of customers also like to have their CodeQL YAML file and then move to a whole new YAML file that runs their SonarQube specific or specific protocols. But again, if you trigger it on the same thing, it just depends on how many runners you want to use, the time it takes to do that, et cetera. So, yes, you had a question, sir. Mm-hmm. So the question is about using an Azure web app deployment slot versus the full fat web app. How many of you use deployment slots? Okay, a couple of you. I love deployment slots because they allow you to create a slot on your production infrastructure and use it for things like A/B testing, blue-green testing, et cetera, and then test it and flip it. You literally flip the switch and swap the slot. You can also direct traffic. So maybe you have a deployment slot and you want to try like 50% of your traffic to that deployment slot. I've used it in instances where customers want to test a feature and they'll literally go 50% to each. So it's great for things like that. In this instance, I'm using different environments because I just want to protect my production environment from the deployment side. From a technical standpoint, if I'm doing testing more readily, I will absolutely put that into a deployment slot. I find the deployment slots are better for the testing purpose. For protecting the environments, I'm using this. I have done this before with staging slots as well. So maybe my staging environment is a staging slot versus a staging environment per se. Does that make sense? The caveat I'll give to deployment slots is staging slots use up your production compute. It wasn't something I knew about in the beginning as well. Starting at Microsoft, and I found this out a couple years ago. So if you have limited compute capacity and you want to do like load testing with Azure load testing, it will hit your production environment. So it's great for testing features, but if you're doing load testing and things like that, spin up a staging environment, run the load testing, and then go to the deployment slot and test that feature potentially. Does that make sense? Yeah, because I've used Azure load testing and completely like literally blown everything out of the water on production environment. Don't do that. Don't blow up production. So I think it's more about protecting production in this workflow, but I do love staging slots. They're fantastic, especially if you're just deploying a website and moving from like the old infrastructure model. It's fantastic. So, yes. Any other questions? Yes.
This is great for a new product, right? But if you already have a large code base, you want to enable code kill, feels like it could be a wall of priorities. Like, how would you manage that situation?
Yes, so the question's about if you have an existing project, how do you implement a lot of these things? I actually enable all this stuff after the project's been built. So the one I showed you with all the errors, code, QL, and Dependabot were enabled after the fact. And I actually used to do the demo where I'd turn it off and turn it on again. Just timing and scanning results, I keep it on now, just for demo purposes, because it's easier. If I turn it off and turn it on, I don't always get the results. It does take about 24 hours to get the dependency scanning going. Most customers turn this on existing projects, not necessarily net new. So they'll say, right, I have a repository, we're going to turn this on and give it a shot. Now, picking a repository that's smart with a project that's in existence is usually probably the way to go. So when they turn on, Dependabot will give you results in about that 24-hour time slot. And then CodeQL, they might start it at the beginning of a sprint, and they'll just enable the basic CodeQL workflow. But again, that's scanning for clear text logging, or excuse me, sensitive data. If you have that in your repository, now's probably a good time to do that on an existing project. Because if you have that existing sensitive data in there, you do want to find it sooner rather than later. Any other questions? Yes?
In one of the slides it said security unit tests.
Yes.
And it was just something I was like, what is that?
A security unit test. That's probably a marketing phrase. So that slide was given to me by the marketing team, unfortunately, for Build when I gave this talk. And it's a good slide, but yes. Some teams use, so unit testing is key. At Microsoft, we use unit testing for pretty much everything. The product teams, I can't show you it today, but I do have a screenshot of one where like the Azure DevOps product teams runs over 50,000 unit tests on every single pull request. We use unit tests all the time. So unit tests are critical. In terms of a security unit test, they can help with the security side. Some people run specific ones that might be testing for something, but because we're running the GitHub Advanced Security, that's covering quite a bit. That gives us the code coverage we need. I saw another hand over here. Yes, sir.
So another question. So GitHub push protection, is there equivalent in Azure DevOps? Like Azure DevOps repos or?
So GitHub push protection, or you mean?
So where you couldn't push up a
Password, yeah. So Azure DevOps does not have this feature built into it yet. The GitHub push protection is part of the GitHub Advanced Security package that you have to enable in your repository. It is coming. We have announced it. We announced it at Ignite this year that GitHub Advanced Security is coming to Azure DevOps. Now, the irony is I'm the DevOps lead. I don't have access to the product yet. Well, long story short, it is very limited access because it is so not ready for public preview. Like they did offer a preview, and I talked to the product team on a very regular basis, and I've asked for a request, like annoyingly so, to get access to it. What they don't want is they don't want people talking about it yet because it is so in junior phases. So this opens up the can of worms about Azure DevOps and GitHub, right? I'll go ahead and talk about this because it always comes up. Azure DevOps is a fully featured informed product with so many great things built into it. GitHub is great, but feature-wise, it's been down here. So they're bringing up feature parity in GitHub to help not compete, but come alongside Azure DevOps. So there's tons of investment in the GitHub side right now. What that means for Azure DevOps is the product team is still here. We had some hiccups in development. So the war in Ukraine took a hit on our team. We have a lot of people in the East. So you imagine that was pretty disruptive. So the team is back now. They are developing on it. New features are coming out. We have an Azure DevOps blog called Dev Blogs on the Microsoft site. They push out product releases all the time. I retweet and repost a lot of the stuff, but there's new features coming out. So that is happening. So Azure DevOps isn't going anywhere, but there's a ton of investment in GitHub because we want to make it better for the developer experience. Why? Because there's over 82 million developers that use GitHub. We want to get closer to the developer and make that a better experience for you. But they are very much separate products, but they do integrate as well. You can run you can have your code in either space. I just did was it a blog? I'm trying to remember. Yes, it was a blog about Azure boards and hooking in, if your code's sitting in GitHub, you can hook into Azure boards and then set that all up. So I did a blog about that recently. That was more towards the IT pro audience who works with development teams and like, well, our developers use GitHub and we're using Azure DevOps, and how do we combine it? So there's so much crossover in the ability for the two products to cross over together and work together. So you can deploy from Azure pipelines from GitHub, you can hook into Azure boards, and then your repos can sit in either or both places. Cool. Any other questions? Yes?
Yeah, about code spaces. So for example, on my laptop, I've got a lot of different programs sometimes running. For example, maybe like a SQL management studio or something like that.
Mm-hmm.
How would you go about running your code space with maybe using different software to test your environment?
Okay, so the question is, how do I spin up a GitHub code space and use third-party software like SQL Studio? So I am not a SQL expert. I know lots of SQL experts that I can ping for an exact answer. How do you hook in your code now to VS Code?
Sorry?
How do you hook in your, are you working in VS Code now, or do you?
Mostly Visual Studio, actually.
Okay, Visual Studio. So you do it very similar to the way you're doing it in Visual Studio, but you're pulling in, I guess, a solution file, right?
Yeah.
The answer is I don't know. I can think about that one, but I don't know. If you message me or find me after, I can ping someone who I know would know. I don't do a lot in SQL anymore, and that is a great question. I haven't tried loading a solutions file into code spaces. Yes?
I want to pick up on this, especially because you are now talking about CI/CD and comparing with Visual Studio versus Visual Code or just code. When should you advise to use Visual Studio and when to advise code? And what kind of project, which tool to use?
Okay, so the question was when to use Visual Studio Code versus Visual Studio. I think this gentleman here had a great example with Visual Studio using solution files and packaging code, absolutely. VS Code is great for development when I don't use solution files in VS Code because it can't handle it. I've never worked, every time I've had solution files in pretty big projects, it's been in full-on Visual Studio. I like VS Code because it's a lighter weight option. So to run Visual Studio, a lot of customers don't have full Visual Studio. So when to use it, if you're doing really heavy development, running solution files in big projects, Visual Studio is probably the way to go. Also, it has been released, I'm putting a blog out on this shortly and a video. You can create bicep files in Visual Studio now. So for writing code, VS Code's kind of been king. For producing projects, Visual Studio's been king for that. So they are bringing some of those features to Visual Studio, like being able to create bicep files. So a lot of people that are doing infrastructure as code are like, that's great, I work in bicep, I gotta go to VS Code over here, then open up everything over in Visual Studio and have that different experience. So they are bringing feature parity across those. But in terms of solution files and big projects, Visual Studio. Yes?
And can I then also imagine that if you need to do other things on code, not only solutions, but also making some UI thing or drawing some UI things, then you go to Visual Studio.
Yes.
If it's only code, then you go to code.
Yes, I would say use VS Code for code, use Visual Studio for things like UI and all those other good things, because it's a more feature-rich product for doing that full development piece end-to-end, absolutely. Anyone else? Yes?
So, pricing-wise for code spaces,
Yes.
imagine they're being hosted as Azure. Is your pricing breakdowns available in Azure, or is it in GitHub, or where is that?
Okay, so the question's about code spaces and pricing. I don't touch numbers. That's what I love about my job. There is a pricing model, but so the code space is spun up in Azure, yes. It's spun up as a containerized environment. You buy the compute. You buy it as usage per time allowance per month. You can increase that. If you're an enterprise customer with GitHub, there's always a way to negotiate prices. Same thing with Microsoft, right? I literally don't touch any of that, so I do apologize. So if you're in an enterprise level environment, there's a way to find that. As a user, you can get, I believe it's 15 hours a month with code spaces but you eat it fast. Or it's maybe 15 gigs of data, I think. It's 15 something. I think it was 15 gigs. I can look at my billing in here and go, oh, I've utilized X amount today. But it is an allocated amount. You can go unlimited or you can set barriers, but it's also based on that compute. So it does, if you do scale up, yes, there'll be a cost associated, but it's tough because a lot of my customers are enterprise. I stay out of that. So when it's a pricing model, that's always negotiable. But they are on the website, I believe, of how they price it.
Just to clarify, so is the other pricing that you're spending available efficiency in GitHub, or is that?
Sorry, so the spending will be in GitHub. So it'll be part of the GitHub pricing model. You'll see a lot of that where something's hosted in Azure, but the pricing's in GitHub as well. So if you think about Copilot, that rubbed people all the wrong way when they started charging for it. The compute sits in Azure. That's how we process it, but the model is through GitHub and GitHub licensing. So you're seeing a lot of that feature parity come up, and then using Azure, leveraging Azure, which is great, but then the pricing's coming through GitHub. Cool. All right, we are not out of time. We've got a little bit more. So let's go here. So right, we talked about code spaces. These are lots of pretty pictures, right? The one thing I'm going to say about actions, they're not just for CI/CD. And that's one of the biggest differentiators of GitHub versus Azure DevOps. Actions can literally automate anything. So I showed you my workflow file. We had a trigger on a push or pull request. I did a chronological job. I could do a cron job and say, every day at this time I have a task I do with PowerShell, or I do this with Bash. I can put it into an action, and every day that task does its thing. Why? Because I want to go on vacation. And we use the kind of thing like the hit by a bus thing, and why we talk about automation. People don't like saying hit by a bus, but it's happened to me. I've lost colleagues over a weekend. I've walked into work after a bank holiday weekend, and people have actually passed away, unfortunately. Automate everything that you do as a daily task. And when I talk to people, I'm like, oh, I can't go on vacation because I'm doing all these things by hand. Don't do that. Automate the things. Go on vacation. Enjoy your family. So I love talking about GitHub Actions. You can customize them. There's so many out of the box. That's probably the only thing I'll show you slides about, is that how fancy they are and how much more they do than just CI/CD. We talked about the demo. So again, this is the GitHub Enterprise Platform that I talked about. We had little pictures before, but that includes code scanning, secret scanning, code QL, and Dependabot, and all those other things that we did. So these are things we went through. Yeah, policy integration. I didn't show Azure policy today, but you can write your Azure policy as code, put it into your workflow file, and do that. We did container scanning. Secrets today. Now, when I did my workflow file, I keep all my secrets in GitHub Secrets. The other thing I actually didn't show you is I'm using the environment capability in GitHub. So if you've used Azure DevOps before and you've used staging, we call them kind of environments in GitHub. So all those environments that you saw in my pipeline are their own environment. I have all their own set of secrets. So there's no crossover. So if one environment gets breached, the others are safe because a breach could happen. So this is effectively what we've done today. We've taken our inner loop. How are we writing our code? Now, again, we did some VS Code. We can go into code spaces. We then push that up to our source control, and then we build and release our code. And now we're seeing everything going back to everything as code. When I started back in tech, there was no GUI, because I'm old. Then all these GUI things came in, and I remember working with a person that was an intern at a company, and he's like, I don't know what to do, there's no GUI. Or sorry, yeah, there was no GUI. It was an old server environment. I was like, oh, that's okay. We can sort you out. So we're going back to everything as code, right? So if you're in the ops space, there's so much more in code. Infrastructure is code, policy is code, all these things. We hook that in, we deploy it, we go into production, we have our Azure container, and then we hook in that monitoring and logging. So I did a lot of that in my pipeline, and then I can hook in that monitoring and logging and then get the results after. I can hook in my app insights into my pipelines. So before I go to that production environment, I can say, oh, I'm failing, or Azure load testing. We can hook all that in to protect that production environment. So we're doing swag as part of this event. Get a hold of the QR code, or you can go to aks.ms/NDC, and you can register for our Cloud Skills Challenge. When you complete the Cloud Skills Challenge, you can get swag. Everybody loves swag. We're also doing that at our booth today. So if you have any other questions after this, these are the resources I used today. I'm also going to tell you about the DevOps Lab on YouTube. We do lots of stuff with infrastructure as code, GitHub. I have lots of things coming down the pipeline in the next few weeks about GitHub Actions and Azure DevOps. So a lot of the content I'm doing, I'm showing it in both with my guests and writing blogs on it because people are using both pretty heavily. Again, feel free to reach out to me later today or any other time with any other questions. Come up to the Microsoft booth, heckle, bring me a drink, wish me happy birthday, all those important things. And if you guys have any other questions, you can ask them now. We can break 5 minutes early. Be really quiet, get more coffee. Did anyone bring any cake? Okay. All right, well, thank you all. Really appreciate everyone coming today, and have a good rest of your day.